This is section 4.5, day 1, similar figures. Our objective today is to use proportions to find missing lengths in similar figures. Let's start with vocabulary. A polygon is a closed, plane figure formed by 3 or more line segments that do not cross. So by closed, it means there's no open gaps. A plane figure means it's two-dimensional, it's flat, formed by 3 or more line segments. So obviously I can't make a polygon with 2 lines. They can't cross, but they have to meet. They also have to be line segments, which means they have to be straight. So an example, a triangle is a polygon. There are 3 line segments. They don't cross, but they meet, and it is closed. That crown-looking shape, it's all line segments. It is closed. It is flat. None of the line segments cross. It is a polygon. Similar polygons are 2 polygons in which corresponding angles have the same measure and the lengths of the corresponding sides form equivalent ratios. In this example, you'll notice that the 83-degree angles are the same, the 53-degree angles are the same, and the 44-degree angles are the same. The corresponding sides form equivalent ratios, so I could set up 50 over 75 is equal to 40 over 60, which is equal to 34 over 51. Let's identify some polygons. Remember, a polygon is a closed plane figure formed by 3 or more line segments that do not cross. Also remember, line segments do not curve. So are these or are these not polygons? Think about it. This first one is not a polygon because these line segments cross right there. The second one is also not a polygon because they cross right there. Third one, not a polygon, it's not closed. This fourth one, not a polygon because this is a curve right here. This last one, yes, it is a polygon. So similar polygons are two polygons are similar if corresponding angles have the same measure and the lengths of the corresponding sides form equivalent ratios. But what is this word corresponding? Corresponding, a pair of corresponding angles or sides are angles or sides that appear in the exact same location on 2 different shapes. Please realize one of the shapes could be turned, so you kind of have to turn it back or turn it in your mind to find corresponding parts. Let's determine the sets of corresponding sides and angles. So let's kind of make ourselves a little table. A part in A corresponds to a part in B. Remember, this figure here is A, this figure over here is B. Let's look at side lengths first. This 2 in A matches up with that 4 in B because they are in the same position. This 7 in A matches up with this 14 in B. This 5 in A matches up with this 10 in B. This 4 in A matches up with an 8 in B. And then let's call this X and this Y. Those go together as well. Now let's look at angles. For the angles, this angle 1 goes with this angle 1. They're the same measure. Let's call this angle 2 goes with this angle 2. 3 goes with 3. 4 goes with 4. 5 goes with 5. You'll notice that all of those sets of angles are all congruent to each other. They have the same measure. So we're going to determine the corresponding parts of these 2 figures. Try this on your own. All right, to do this, these ones are labeled for us. Let's start with G prime. G prime goes with M right here. You kind of have to turn it in your mind to make them line up. So let's go M prime goes with this guy right there, Q. K prime, that apostrophe we call a prime, by the way, goes with D. J prime goes with this big one over here, that's O. And H prime goes with N. All right, angles are always labeled with capital letters. So we've got H prime goes with B. G prime goes with A. M prime goes with E. K prime goes with D. And J prime goes with C. Those are our sets of corresponding parts. Now let's look at if these are similar. To determine if they're similar, all the corresponding angle measures have to be the same. These are the same figures we looked at before, but let's just recap. I've got a 90-degree angle here and a 90-degree angle here. They're the same. I've got a 90 here, and this 90 corresponds. They're the same. I've got a 225 here and a 225 here. They're the same. 45 and 45, again the same. And a 90 and a 90. So all corresponding angles are the same measure. That is the first thing you should always check. Now, all corresponding side lengths have to be proportional. So let's start setting up proportions. 2 goes with 4, so we're going to write 2 over 4. 4 goes with 8, so we have 4 over 8. 5 goes with 10, so I've got 5 over 10. And 7 goes with 14, so I've got 7 over 14. We do have one missing set of sides which should be given to us, but we're going to do the problem with that. So if these are similar figures, all of these ratios will be equal. Well, 2/4 simplifies to 1/2. 4/8 simplifies to 1/2. 5/10 is 1/2. And 7/14 is 1/2. Since all of these ratios are the same, and all the angles are the same, then yes, they are similar. So look at these two and determine if they are similar or not. All right, remember the first thing you should always check is angles. This angle right here goes with this one over here. I've got a 104 and a 102. Well, those corresponding angles are not the same, which means no, they are not similar. Always check the angles first. All right, now let's look at these two. Are they similar? Try this on your own. All right, first we check the angles. In the smaller figure, all the angles are 90, and on the bigger figure, all the angles are 90, which means any way I line them up, they're going to be the same. So let's set up some proportions. 20, go with 30, because those are the shorter sides. So 20 over 30. And 30 goes with 50. Now, normally we would have to set up the ratio for all the sets of sides. But since this one is 20 over 30, and I've already written that down, this will be 30 over 50, and I've already written that. I don't have to write those two down. The other important thing is that whichever figure you choose to put on top of one ratio, you put on top of the other ratio. So I chose to put this one on the top and this one on the bottom. That's fine. You could have flipped that and had the little one on the bottom and the big one on the top. You'll still determine whether or not they're similar as long as you keep it consistent. So to check this, let's do cross products. 30 times 30 is 900. 20 times 50 is 1,000. These are not equal, so they are not similar. And one last one for you to try. Are they similar? All right, the first thing we check is angles. I've got 90 and 90. 53.13, 53.13, 36.87, 36.87. Angles match up. So now we try sides. 6 is the smallest side, so it goes with the smallest side, which is 3. 10 is the biggest, goes with 5 is the biggest. And 8 is the missing one, goes with 4. 6 over 3 reduces to 2 over 1. 10 over 5 is 2 over 1. 8 over 4 is 2 over 1. Since this is a proportion, then yes, they are similar. Here's your